iiTutor. Today we are doing mathematics, grade 12 mathematics. Our main focus is on the topic analytical geometry, or rather some people know it as coordinate geometry. And as we start off, we're going to start with the basic formulae of analytical geometry. You know, equation of a straight line. Number one, the first key one, equation of a straight line. We have equation of a straight line y equals to mx plus c, or rather we can use gradient point form, being y minus y1 equals to mx minus x1. So right over there. And then when we are dealing with a triangle, right angle triangle precisely, we are using Pythagoras theorem. This is ab squared equals to ac squared plus bc squared. So we know this guy because we've been dealing with him since grade 9 or grade 10. We are using this formula when you either calculate this is your right angle triangle, A, B, C. Therefore, you have your hypotenuse there. You have your angle right over there, your theta right over there, making this your opposite, and then this your adjacent. So we are using this formula when calculating either of the sides right over there. Great. Now let's get to the distance formula. AB equals to root of xa minus xb squared plus yb minus ya squared. We are using this formula when calculating the distance between 2 points, being two points A and B. So whenever you want the distance between A and B, this is the person that we are using. Right. I hope I'm clear on that. And then we get to the gradient. The gradient is the steepness or the slope of the line that is given. You see, this line, it is inclined to a certain angle. So when you need the steepness of your line, this is what we use. The gradient of line AB is equals to ya minus yb divided by xa minus xb. Well, mathematically, we just say changing y divided by changing x. This gets me thinking, you know. Tan theta is also changing y divided by changing x. So we can conclude that gradient of a line is also equals to the tan theta of the very same line. Changing y divided by changing x, which is being your opposite. This is your y axis, right? Your opposite and your adjacent. What is your adjacent? Your adjacent is on the x-axis. So this has to be tan theta, right? You know, on your line, we may need to calculate midpoint sometimes. And this is the formula that we are going to use. The midpoint of line AB is given as, when you calculate the coordinate of your x, this is what you use. xb plus xa divided by 2. When you calculate the coordinates of your y, yb plus ya divided by 2, you will get the coordinates of your midpoint, right? But then when we get to the points on the same line segment, we know that your gradient will be the same throughout the line as long as you are dealing with a straight line. For instance, you are given C right over there, and then you already have the gradient of your line AB, and then you need to find the gradient of C. What is it going to be? It's going to be the same throughout. For instance, your gradient is 2. That means if you need a gradient of C, you're still going to have 2 as the gradient. If you need a gradient of D right over there, it's still going to be 2. It never changes as long as it's on your straight line. Parallel lines. Parallel lines are the lines that never meet. So if your lines are parallel, it means they have equal gradient as well. So the gradient of line AB is equals to the gradient of the line CD. That's just how it is. Just look at it. You know, the angle that you will have there is equals to the angle that you have there, as long as your lines are parallel to each other, right? Perpendicular lines. Perpendicular lines are the lines that are making a 90 degrees when they cross or wherever they meet. So this is a 90 degrees angle that you have in between line AB and line CD. Gradient of line AB multiplied by the gradient of the line CD equals to -1. That's just how it is. So this is very easy. Angle of inclination is an angle between the positive x-axis and your given line. And the moment the gradient of your given line is greater than 0 or being positive, we are going to have an acute angle. So the angle between your x-axis and your given line will be less than 90 degrees. But if your gradient is greater than if your gradient is less than 0 or being negative, we are going to have our angle of inclination being an obtuse angle, meaning an angle that is greater than 90 degrees but less than 180 degrees. This is what we are having right there. And we should note very well that if our gradient is negative and then you punch it on a calculator, your calculator is going to give you an angle in the fourth quadrant. So you'll get an angle this side. What you have to do is to add 180 degrees to that angle so that it gives you an angle in the positive x-axis. That is practically all about angle of inclinations. We will get more on this when we are going through the questions. Now let's do an equation of a circle. So fellas, let's get to an equation of a circle. This is how we get an equation of a circle. Remember, we have two equations of a circle, being x squared plus y squared equals to r squared. That is when your circle is centered at the origin, being your origin 0, 0. And then we have another equation of a circle when your circle is centered at AB. So this is x minus a squared plus y minus b squared equals to r squared. So we need to understand how we came about with x squared plus y squared equals to r squared and how we came about with the second equation. So here's what we do here. We have our circle and then our radius, and then this is our point P, and then this is our point C. And the coordinates of point C are 0. Why? Because our circle is centered at point C, or the origin, and then our point P is x, y, right? So to do that, we calculate the distance between point P and point C. And what is our distance formula? So distance of CP equals to root of x minus 0 squared plus y minus 0 squared. So what we do, we get rid of the root. And then how do we do that? We square it, leaving us with CP squared equals to x minus 0 squared plus y minus 0 squared. This is what it leaves us with. And when we further calculate this, getting rid of the brackets or simplifying this more, what is your x squared? X squared is equals to x squared minus 0 squared, so minus nothing, because 0 squared is actually 0, so minus nothing, plus y squared minus 0 squared, which is nothing. Therefore we are having our radius as this. This is our radius. Our radius, the line from the center to any point on the circumference. This is how we came about with that. But then, now, let's get to a situation whereby our circle is not centered at 0. Our circle is centered at point A, B. We still know the distance formula. You have to calculate the distance between point C and point P, and that gives us CP as root of x minus a squared plus y minus b squared. Sorry about that if the marker is not visible. Therefore, we get rid of our root by squaring. We do the same thing, and then we will have CP squared as x minus a squared plus y minus b squared. And then as we simplify this, we are going to have, actually, we are done. We are done, because this is that formula. We were actually trying to find a way of how we got to this formula, and here it is. Nice. So we only apply this rule. We only apply this formula when your circle is centered at point AB, not when your circle is centered at 0, or sorry, at origin. With the circle, this is the section that is very critical. You need to memorize these equations because they are not written on your formula sheet at all, right? So as we go through the questions, we realize that there are some questions whereby you're given 2 circles, and then as you're given the 2 circles, they may ask you whether the circles meet, in fact the circles touch at one point or intersect at 2 points, or rather they're doing neither of the 2. So this is what you need to know. When your circles are touching, when one of your circles is touching the other circle internally at one point, while the distance between the center of the centers of the circles is equals to the difference of the radii of the circles. You need to catch that statement very well. If ever your circles are touching internally, well, you need to know that the distance between their centers is equals to the difference of their radii. That is on your circle number 1. Circle number 2. When your circles are intersecting at 2 points, the distance between their centers is less than the sum of their radii. That is your circles number 2. When we get to circles number 3, when the circles are touching externally at one point, the distance between their centers is equals to the sum of their radii. Check the difference here. When they are intersecting, the difference between their centers is less than the sum of the radii. But when we get here, when they touch externally, the distance between their centers is equals to the sum of the radii. But then when we get to where the circles don't touch or they don't intersect at all, meaning one circle is a bit further from the other circle, the distance between their centers is greater than the sum of their radii. I hope that is clear.